right, so let's begin. Good morning, good evening, everyone, depending from where you are watching us. My name is Afonso Solak. I'm civil engineer. I work for the software development department of CYPE. Today, 2nd of June, we will start with this presentation that is part of this cycle of workshops that is called Discover CYPE 2021. Okay. So this cycle was started in the past February, in 24th of February, with it's part of 26 webinars that were made by 7 different speakers from CYPE. Okay, showing 15 different open BIM tools to develop a complete BIM model. Okay, so in February we started with the 3D model, creating this 3D model with CYPE architecture. Then we have been discovering different tools to generate the graphic documentation, the view of quantities, the structural models, plumbing facilities, electrical facilities, lighting installations. So the different disciplines that we have in a building project. And today, that is 2nd of June, we will be doing this one here: clash detection, BIM coordination, and model checking using IFCs. Okay, so at this moment, we already know that we have different IFCs in a project. Okay, so the system, the ecosystem that CYPE provides work with IFCs, and at this moment our project it's full of IFCs, so different IFCs, and we can have clashes between these IFCs. What it means, we can have different elements from our models that can occupy the same space in the project. So that could be impossible if we decide to construct this model. So we must check if we have these kind of situations to reach a more accurate model. Okay. For that, we will use one tool that is called Open BIM Model Checker. Okay, so we will use this Open BIM Model Checker to we will import the different IFCs in this tool and then run the clash detection analysis. Okay, so just showing where you can download this tool. It's available as the other softwares at the BIMserver.center store. So you can look for that on the store. Open BIM Model Checker. Okay, the software have some parts of the software are for free. Some of them are paid. So we have different tools inside of the software. We'll be looking with more details in a few moments. And part of the software is for free, part is paid. Here you can find more information about the software, as other tutorials, seminars, some guides to start working with this software. And you can also download the software here using this button. Okay, so the software is available in different languages: Chinese, English, French, German, Italian, Polish, Portuguese, Russian, Spanish. So you can find here different options to start working with this tool. Okay. At this moment, I have the software installed on my computer. It's already running, but I would like to show you a little bit the project that we'll be analyzing in this software, in this workshop today, just to have a context what we have, what kind of information we have, what is the status of our project at this moment, to use one software to run a clash detection analysis. Okay, so here at BIMserver.center, in my projects tab, okay, I have different projects, and the software and the project that we will be working today is this one here. It's called Intro Open BIM. Okay, so we have 13 different team members working in the same project. We can open this project here, and here we can see the recent activity of the project. So we have different people working with different disciplines. Okay, so different professionals with different specialties working with different disciplines. And in the content tab, we can see the different files that were created by these people. So as you can see here, this guy here, Rafael, created the architectural model, and this guy here created the landscape model. This one here created the structural model. So we have different people working in the same project. That is one of the main characteristics of the ecosystem of CYPE, or the BIMserver.center platform, so we can work in the same project in a team, with a team working in simultaneously in the same moment from different computers, from different softwares, to get for together generate this model, okay, this federated model, as we usually say when we are talking about BIM. Now, in the end of the project, we must check if this IFCs created by my colleagues in this case, if they clash in some point. Okay, so we must introduce these IFC files inside of Open BIM Model Checker. Okay, all the softwares that we have here in the platform, if we go, for example, to this situation here, the architectural model that was created with CYPE architecture. These softwares, this is CYPE architecture, okay, they have this menu here to export and update information. So we can send the information from this software to the cloud, and then from the cloud to another software, or to another person in this case, okay, that is using another software. For that, we use a synchronizer. This is the synchronizer, the BIMserver.center sync, okay, where we can manage the softwares, the projects that we have in our computer. To work with Open BIM Model Checker, the situation is the same. We will use this buttons here, this menu. You see that inside of Open BIM Model Checker, we have the same situation. And then we can send and receive information from Open BIM Model Checker. The only difference is it's going to be that, for example, here in CYPE architecture, we started exporting information to the cloud. And in Open BIM Model Checker, we will start updating information from the cloud because we want to import the other IFCs to Open BIM Model Checker before we start our analysis. Okay, so let's go. Let's start with this program. So I have here Open BIM Model Checker. We are using the last version of Open BIM Model Checker that was released just 2 days ago. Okay, so the 2021D. So it's the last release that we have at this moment. And as you can see here, you can see my picture and my name here. It's because I'm connected with my BIMserver.center account in this software. Okay, so I will start with a new clash detection analysis. For example, clash detection with the name of the project, intro Open BIM, for example. So I'm creating this file of clash detection analysis, and then I will select the folder that I have in the BIMserver.center, or the project folder. This folder here, okay, this folder with the IFC files. So this folder here, I can select this one inside of this software. So let's select this project, intro Open BIM. So let's accept, and now we will select the files, which IFCs we would like to include in our analysis. So here we have different files. For example, the structural model created with CYPE, we can include it, or the water systems developed with CYPE plumbing water systems, the sanitary systems with CYPE plumbing sanitary systems. For example, the model of the landscape created with CYPE architecture, or the architectural model, the building model in this case, also with CYPE architecture. So we can include the files that we want to analyze in this phase of the project. In some situations, some of these files don't have any geometry. For example, the bill of quantities that was generated with Open BIM quantities don't have any geometry. So we will not analyze the clash with something that don't have a geometry. So in this case, I will not import the Open BIM quantities. Or in some situations, we can have similar information. For example, in this case, the construction systems were developed both in CYPE architecture and Open BIM construction systems, two different softwares that have similar information. We can choose between them which one will be part of our analysis. Okay. Once we define the files, the IFC files that we want to import in our project, we just have to accept that, and Open BIM Model Checker will import and obtain the data from the cloud, download this information from the cloud to the environment of the software, and we can run this analysis. Okay. Depending on the size of this project, depending on the number of of disciplines that we have, this process could be faster or slower. Of course, if we have too many information, this process will be a little bit more slower. Okay, so yeah, we are just importing. If we don't have the files in our computer, the synchronizer will be running in and downloading this information and saving a copy of these IFC files in a local folder. So this is the default local folder where these files are saved. But we can also change this and choose a different one. Okay, and if you see if you find a trouble, you have a situation that you cannot import or you cannot download the files from the cloud, it's probably because this synchronizer is not working. Maybe it's stopped or it's power off. So you can turn it on here, okay, using these buttons here. Okay, so we are importing here. Just to be a little bit faster in the presentation, I already have a copy of this project with this process of import IFCs to the program to the software done. So once you finish that process, you have the BIM model inside of Open BIM Model Checker. Okay, so this is the BIM model here at Open BIM Model Checker. And for example, this is the same model here at CYPE architecture, in this case, just the building. Okay, so this information was sent to BIMserver.center and then sent from BIMserver.center to Open BIM Model Checker. Okay, here we have more information because we have more IFCs. Okay, not just that IFC that I showed before. All right, so let's start with Open BIM Model Checker. Actually, it's a very powerful but very easy to use software. Okay, so the first thing that we can do with the software is to visualize the information. Here we can consolidate the model. So here we can import all the IFCs and visualize the information using three how can I say three classifications. Let's say. So we can visualize the project by floors. So for example, let's suppose we would like to see just the level, I don't know, 5, for example. We can deactivate all the other levels, and everything that is in a different level will be invisible, will be deactivated. Okay, so here we can choose just one level, for example. Another way, let's activate again here the levels. Another way to show or to inspect the model is by models. So here we can see that those IFCs that were imported, the water systems, the structure, sanitary systems, architectural model, and landscape are available here. And we can, for example, deactivate part of this one of these models. So for example, let's suppose we would like to deactivate the landscape. So we can deactivate the landscape. Some of these models can have some how can I say some layers of information. For example, here in the architectural model, we have a layer of information that is the construction elements, the furniture, and the bathroom fittings. So and the spaces. Okay. So if we activate the spaces, we can see the spaces inside. In this case, I think the spaces don't have color, so it's a little bit difficult to see. But if we deactivate, for example, the construction elements, so yeah, we deactivated just the construction elements, but as you can see inside of the model, we have also the furniture and bathroom fittings activated. Okay, so if we deactivate in this case the bathroom fittings or the furniture, yeah, now we have all the architectural model that is invisible. Okay. So you can work with these options here to deactivate a complete model or part of this model. Okay. Another option is, if we minimize here and open this one, is by categories. Okay. So inside of this model, we have different categories, different types of elements. So for example, we have doors, columns, booster sets, beams, we have furniture, we have pipes, we have, I don't know, railings, rail supports, different parts of the model that we can also deactivate. For example, if we deactivate just the doors or just the elevators or just the columns or just let's see the floor slabs. Let's see where are the walls here. So just the walls, for example, we can deactivate by category too. Okay, so that could be very useful, because in some situations we are inspecting the model, looking for some issue, and deactivating the model or part of the model is very useful. Okay, it's interesting because we can combine the filters that we have here in the categories tab or categories menu, let's say that, with the models and floors. So for example, we could deactivate everything that is related to the water systems as is now, and for example, and the sanitary systems, and for example, deactivate the furniture. So we can combine all this information, activating and deactivating these checkboxes that we have here. Okay. Another way to visualize the information or to inspect the model, let me activate again some of these categories here, is manually deactivating or hiding part of this model. Okay, to do that, we can use, for example, this button here, hide selection. Okay, if we click on this button and click in a specific part of the model, we'll deactivate this model, okay, or this element. That could be very useful. For example, we can create a kind of tunnel. Let's say we would like to inspect inside of something. We can open the model and zoom in and deactivate information and reach a part of the model that was not visible before. Okay, so we can use this tool to deactivate a single element, for example, but we can also use the same tool to deactivate part of the model, just selecting using just using the mouse to select multiple elements. So I would like to deactivate all this part that is in orange. We select first and then confirm with the right button, and we can deactivate part of the model. That could be very useful again to see what is inside of the building. Okay, if we'd like to come back and see the building again or the complete model again, we just have to use this button here, show all, and the information will be back. We are not deleting the information. We are not changing the information. We are just consulting this information and changing the visibility of this model or parts of this model to inspect, to easily inspect the model. Okay, we are not changing the information. This information was created by another colleague, another professional in another software. And if we'd like to change the information, we have to come back to these softwares and change the information there and synchronize with the platform again, sending and receiving information through these buttons here. Okay, but here we can check the model, we can visualize the model. All right. Another interesting tool, or another set of tools, is this menu that we have here. Okay, here we can change, we can create sections. So for example, we have these three color axes here, the blue X, the green X, and the red X. And if we create, use for example a section perpendicular to the blue X, we can create this kind of sections here. Okay, so that's another way to inspect the model. Okay, we can combine sections. We can create 2 or 3 different sections at the same time. Okay, and then we can see inside of the building. If we double click on one of these arrows here, we invert the selection. So we can double click in an arrow, and we can see in the other side. Okay, or we can cut in the other side, the opposite side of the arrow. Okay, so that could be very useful too. Okay. All right. Another tool that maybe is very interesting for us if we are inspecting our project is to see what is the information that is related to each part of the geometry of our BIM model. Okay, because BIM model is building information modeling, so the I information is very important for us, and we know that we don't have just geometry. We don't have just a simple 3D drawing. We have a model with information related to each part of this model. If we click on this button here, show information, where we click, or we don't have to click, we just have to go through the element. We can see the information that is related to this element. So here, for example, we have a floor slab with this thickness, with this name. Here we have a railing with these other parameters that are related to railing. Here we have a window with different parameters, so we can see, we can read the information of each part of the building. So in some situations, for example, when we have pipes, we can have different pipes or different type of pipes in a same building. The sanitary systems, the water systems, the HVAC system, maybe some pipes where we have electrical facilities, and the pipes are always a pipe. So we can use this information, this button here, to show the information of each pipe to see, this is I don't know, a sewage pipe or a water supply pipe, using the information button. Oh, that's very useful. Okay. Another option is, in some situations, for us, it's could be more easy to inspect using the monochrome drawing. So we can also change the color to black and white. Okay, that is another option that we have here. Changing the colors, we can also change the transparency of the buildings. So, for example, let's suppose that we wanna see through the building, but without deactivating all the model, for example, or all the walls of this building. By clicking on these buttons here with the right button of your mouse, you can change from the normal color to the transparent drawing, for example. So this discipline or this model, the architectural model, now is transparent. We can see a little bit about this model. We can also consult the information related to this model, but it's I don't know, 50% transparent. It's not invisible, but it's not opaque. We can see a little bit about this model here. And there is a third way, a third type, that is the wire drawing. So we can click on that, and we have this situation. So here we have just the lines that are related to the geometry of the architectural model in this case. This is very useful. Again, we can see that the structural model was well introduced in our architectural model, and inspecting the whole building using this wire frame, it's a very interesting and very useful way to conclude that. Okay, so as you can see here, the lines are in a gray color, and it's another way to inspect the model. Okay, we can do that with everything. So here we did it with a model, but we can do with one of the specific categories. For example, just the booster sets, or just the furniture, or also here, no, just in this case that we cannot do that with levels. We cannot do that, but with the models we can use this resource. Okay. Okay, so these were the options that we have to inspect the model. Okay, but let's suppose that when we were inspecting the model, I don't know, let's deactivate, for example, this floor slab here. We saw this systems here. We saw that we have some footings here. Okay, so some foundation elements, and we have this pipe here, the horizontal circular pipe section with this information. Okay, we clearly see that we have this pipe colliding or clashing with this foundation element. Okay, it was very easy to see that because it's here. Okay, so a first way to notify someone of our project that we have this issue is by creating a new issue. Manually create a new issue. We'll run a clash detection analysis in the future, but I would like to show before that we can also create these issues that are, how can I say, that are very easy to find, and maybe before running a clash detection, we can create one issue because it could be useful to create these kind of issues. So in this case, I would like to inform my colleagues those colleagues that have been working in the structural model and in the in this case water sanitary systems model, that they have a problem here. Okay, they have to change something because this is impossible to construct. Okay, so I'll create a new issue. In this case, I will say we have a sanitary pipe inside of a foundation element. I don't know. I'll create a name for that. Could be a code, for example, depending on the way that you work. You can create a kind of list of codes to identify these issues, and then I'll describe that. So, for example, I'll say we have a sanitary pipe inside of the foundation element. Probably we have to change the pipe because maybe it's impossible to change the foundation element. In this case, for example, okay. So here we can add a text explaining what happened here. What's the problem? Okay. So this new issue, I will accept that, and then I'll select the elements that are related to this issue. Okay. So in this case, for example, we have this foundation element and this pipe. Okay, so I'll select the pipe and the foundation element. We can also select, for example, maybe this bin here, because this bin is in the same pipe. Okay, it's also colliding with this pipe. Or we can also select this other foundation element here and the other bin. So we can create issues with different elements. Okay, when we select one of these elements, once we export the information to the platform, the softwares or the professionals that have been working with these elements or creating these elements will be notified about this issue. So here it's the way that we are informing someone. I'm not telling someone or using a email or an app to send a message to someone telling that there is a problem with their foundations. I'm just clicking on the element that was created by this professional, and the platform will automatically notify this professional about the issue. Okay, so I selected these elements, and by right clicking, we generate the issue here. Okay, so the issue number 1 was created, is pending to solve. In this case, it's not solved yet. Okay, here we will create our checklist. In this case, it's not created. A picture or a snapshot was made. So yeah, the information was added here. Also a graphic information. We can also complement this information or change the text of this issue. Okay, we can add more information. For example, we have a sanitary pipe. Let's suppose I will paint the sanitary pipe in red, for example, inside of the foundation elements that I will paint in, I don't know, in yellow. Okay, so we can paint the information here, and then we can, for example, put the horizontal pipes in red and the foundation elements in yellow. Okay, so with that we can change the information, we can classify the information, we can update this picture here, for example, because now we have colors. So let's zoom in, and for example, let's take a new picture here, and the information is updated. Okay, so that's very useful because we can use these colors, we can add information, we can take a picture, and we can also add some annotations. In this case, for example, let's suppose I would like to put an arrow here just to be easily to find. I don't know, just adding some information. We can change the color of these elements. We can add distances and angles. We can add areas. We can add different annotation elements here. Okay. We can also add a symbol, a reference point. It's just a sphere like this one. Maybe we can put here or in a place that we would like to show where is this issue, because when we are with the model in this case, for example, we see all the model, maybe this red dot, it's easy to find then the annotations that we included before. Okay, so we can use these resources too. Okay, So this is an issue. This is how we create an issue. This issue was created manually, but it's in some cases this it's necessary. Okay, but in this case, what's the best solution for this problem? Change the foundation element or change the pipe? Okay, I don't know, but I suppose that changing the pipe it's going to be easier. Okay, so I can inform just the author of the project of the sanitary systems project. So by clicking here, I will select who will receive the notification. Okay, so in this case, if I check just the first one, just the horizontal circular pipe, just the guy that introduced the pipe will receive the notification. But if we click in both of them will receive this notification. Okay, so we can select. In some cases, we will know, and then we can just select one of the elements. But in some situations, it's going to be difficult, and those professionals should discuss between them which is the best solution. So you can inform both of them, but by selecting all the elements here, the elements that are waiting for a review. Okay. All right. So now we know how to create the issue, how to inform other professionals about the problems that we have in the project, and of course, these professionals they should open their softwares and change the information in their own softwares, not here at Open BIM Model Check. Okay, so they have to change in the design softwares that they have. The next step would be the clash detection. Let's suppose this one it was very easy. We saw this situation when we deactivated this lab or the floor slab that we have here. But I'm sure that we have much more problems like this inside of the building, and it would be impossible to know where are all of them. So it's when we can use the clash detection analysis. Okay, so this is something that is one of the main features that we have with the BIM technology. Okay, so these kind of tools are very powerful, and we can find a lot of surprises that we could have in our model. Okay, so let's create one of these analyses. So I will combine. We can combine different files in the same analysis. So for example, let's create a first one. We can create a new file combination. Let's suppose the first thing that we can do is select everything here, all the models, and run a global analysis. But in some cases, that could be very complicated because in an earlier start of earlier moment of the project, we can have a lot of issues. We can have a lot of issues, and if we select all the disciplines, that could be difficult to analyze because we will receive too many data, and probably most of this data could be corrected, or most of these issues could be corrected with just some changes in the project. So maybe it could be a little bit easier if we select different files and analyze these files separated. For example, we can run an analysis that could be the structure versus the sanitary systems model. For example, sanitary systems model. Okay, we can create this combination here. So I'll select the sanitary systems and the structure. Okay, both of them. Then in the future, I will run a second analysis that could be the structural model and water systems, and then the structure and the landscape or the architectural model and the sanitary systems. So we can create different analysis. In this case, these two models here. Okay, I will accept that, and this file combination was created. The analysis was not carried out yet. Okay, so we just created this file combination. So here we can create a strategy, a list of file combinations. So a second one could be, for example, the structure and water systems, and we can leave this second file combination here: structure versus water systems. Okay, and then a third one could be I don't know, sanitary versus water systems. Okay, so we can create these different combinations here. Once we discover what's the best strategy to analyze the model, we can run those file combinations, just pressing on this button here, detect clashes. So in this case, the software will start analyzing this one. You saw it was just, I don't know, 10 seconds or something like that. And we found 165 different different clashes in this model, okay? Just between the structural model and the sanitary systems model, okay? Just between the structural elements and the pipes or the different sanitary pipes that we have on the model. We can see these clashes here, okay? We can see these clashes here. So we have this number 165. We have it here, okay? 165 clashes, okay? In this list of clashes, we can see some information, okay? Let's open a little bit more this one here, like maybe like this one. So in this first one, the first clash, the number one, we can see that we have a clash between a beam, the beam number 12 with this size, and one of the pipes, one pipe that have this name here, zero H pipes with 2%, okay? We can also see that that is a beam and that is a pipe, not just by the name of the elements, but also because it's by the categories. We can see that is something from the category beams and something from the category pipes, okay? That's very interesting because in some situations, let's see here, in some situations, depending on the model, the information that we have here on the name of the files, it's based on codes because it was automatically generated, or because it's from a specific catalog of a manufacturer. So in some cases, this information is not too easy to understand, depending on how this information was introduced on the design software. And with the categories, we always can see which is the categories of these clashes, okay? So in this case, we have this situation. We cannot see too many information here in our model. So we can use, for example, the full window. We cannot see the information yet, but we can use this button here, show only the elements involved in the clash. So if we click here, now we can see that we have this problem here, a beam and a pipe. Okay, so a beam in a pipe, and we can see that this pipe, it's clashing a little bit the bottom of the beam. Okay, so yeah, here we can see the information. Okay, so this is one way to identify a clash. Okay, now we can transform this clash that we found in an issue. Okay, maybe it wasn't a clash, it was just a problem that we have because the model is not finished yet, or it was a criteria of our model. I don't know, depending on the project. But in this case, let's suppose it's a problem. We have to solve this problem here. So let's click on this on this on this uh, clash, okay? And using this button here, we can generate an issue from this clash. Okay, so when issues are going to be generated, do you want to continue it? Yes, I would like to continue. And the issue was generated. Okay, if we see here our number, now it's gonna be less. Okay, we can come back here to the issues, and you can see that that clash was transformed into an issue. Okay, here we can also add more information. So for example, let's suppose that we will suggest a solution for this problem. So the pipe should be moved 2 centimeters I don't know, lower or something like that. We can add information here. And in this case, I will not inform the author of the structural project, just the author of the sanitary model. Okay, so it's the same system. Who will be informed? Which the information we would like to add? We can also take a picture of that as a normal issue. So we can use the clash detection tool to find the clashes and then transform these clashes in issues that will be sent to the platform, to our teammates. Okay, we can do more things here. For example, one of the things that we can do, let's see other situations here. This one is very interesting. Here you can see the the pipes inside of the beam. So of course it's a clash in this case. We have to look for a solution for that. So just clicking here, we can create the issue. This another one. Here we have something that is similar here. Okay, so it's this situation here. Let's click. So here we can click in different issues and automatically create different issues from the clashes just by selecting those clashes that we would like to include in our inform of issues. So let's suppose I would like to inform these guys here. So I selected all of them and then generate the issues. So now I'll create 7 different issues. Let's accept. And let's come back here. And here in my list, I have different issues with different elements that I could add more information if I would like to add more information. Okay. All right. So this is how we can transform a clash in an issue. But let's suppose that using this system in some situation we can have too many issues. But I don't know. Let's suppose we have a problem that is a vertical pipe that is clashing with the different slabs or different beams that we have in all the levels of the building. So it's the same pipe in different with different beams. Okay, I don't know if we have this situation here. Maybe this one here. Okay, so this pipe here, it's in this case clashing with some structural element, but probably we will have the same situation in the floors above or the other floors. Actually, you can see this is always the same element with different floor slabs. One situation would be, let's select everything here and create different issues with these clashes. But probably by solving the first one, we will solve the others. So one option could be, so let's inform just the first one. For example, let's create an issue with that, and the others we can delete from our analysis, because we know that when we change the first, we will also solve the others. So you can select these guys here and delete the information, delete these clashes from our list of relevant clashes, let's say that. Okay, so we can delete the clash from our analysis. That could be useful, and sometimes we can have less issues and think about a little bit more about the type of issues that we have, or how we are informing our colleagues about the problems, and not by just selecting all this information and sending to the team. Okay, so we can manage the clashes here. Okay, if we use this button here, the edit button in one of the file combinations, we can see the discarded clashes. So those clashes that we discarded from the main list, they are here. In any moment, if you want to, we can send these clashes back to the list. If we send this information to the discarded clashes by mistake, for example, we can send back to the main list. Okay, so here we can find this information. If we run a new analysis using the same combination, this information will not be shown here on the list. Okay, so that could be nice, because during the analysis, you can how can I say, you can you can be more precise in your analysis by classifying in clashes that are relevant or not. Okay, so using this system here. Another option that I think could be very interesting is you can run analysis not just by combining two models or two or more models. You can combine, for example, parts of the model with parts of another model. So for example, let's suppose in this case we made one that was the structure versus sanitary system, but let's suppose I would like just to check how the foundations, for example, collide with the sanitary systems, for example. So in this case, we will select the models, the structure and the sanitary systems. But here, for example, in the structure, we can select just the foundations, okay, just the foundations. So I will deselect the floor slabs, column, and beams, and we'll leave just the foundations. Okay, that could be very interesting because some models could be very complex, and analyzing the projects like this with this kind of filters would be very maybe it's going to be faster or it's going to be easier. So we can, in this case, in the sanitary systems, we have hatches and pipes, and here we have different elements. In the architectural model, for example, we have other elements, other categories. So in this case, just the foundations. I'll create this file combination. Let's run the analysis. And here we can find just 17 clashes that are related to the foundation and the sanitary systems. So these clashes here. So that's another way to have a partial analysis of the model, okay, or of one of the models, okay. All right. So we saw how we can inspect our model by displaying different parts of the building. We saw how to create an issue. We saw how to run a clash detection analysis. And here we can also check the documents that are related to these IFC models that we imported to the program. So some of them can have related information. So the water systems in this case have the view of quantities, for example. So that would be a nice way to check the documentation that is related to the model. So here you also have these documents. Okay. The last thing that we must do is send this information to the team and see how the team will receive this information. To do that, let's export the model to BIMserver.center. So we will generate a new IFC, in this case, IFC with the name that we would like to use. Issues found by Afonso, for example. Let's suppose we are a team of BIM coordinators or BIM managers or BIM checkers. Let's use that term. And we are more than one professional working in this phase of clash detection analysis. So we can have different files of Open BIM Model Checker, and we can generate different IFCs with different issues. Let's suppose I will check just the issues related to the structural model, and a colleague will run a new analysis just analyzing the architectural model. So we can separate the work by working with simultaneous analysis with different files here inside of Open BIM Model Checker. Okay, so issues found by Afonso. Let's suppose that I'm doing just structure versus sanitary systems. Okay. So this is going to be one layer of information, one more layer of information in our project. Okay. And this information was exported to the platform. If we open the synchronizer at this moment, we are uploading the information to the platform. And also this information is uploaded, those colleagues that generated those models that were mentioned, that were selected in our issues, we will receive a notification about these issues. Okay, so let's wait a little bit until this information is uploading. Okay, here inside of the platform, let's suppose we are one of these professionals that are related to the issues. We can find the notifications in this tab here. Okay, we can find this information here, the notifications tab. Okay, and here we can find the pending issues that someone identified. Okay, so for example here, it was this is one of the pending issues. So the BIM 16 versus the horizontal circular pipe section. Okay, so I requested to Nuria. Nuria is the professional that makes the structural model. That using this file that we created now, the file issues found by Afonso, structural versus sanitary, that we have a clash between 16 and horizontal pipes. Okay, BIM 16 and horizontal pipes. So if with this information, Nuria received here in this button here one of these notifications. For example, a new issue that must be solved, clash BIM 35 versus this one here, okay? It's inside of the file sanitary systems in the project intro open BIM, okay? Because maybe I have different files and different projects, so I can receive this information. I can also set the parameters here at BIMserver.center to receive these issues by mail and also in my mobile phone if I'm using the BIMserver.center mobile app, okay? So we can manage these issues also via mobile phones, okay? Once this issue it's modified, if we solve the problem, we can check here, for example, and mark this issue as solved, okay? It's like a checklist. And we can also check this information inside of the program. So we can come back here, and in our list of issues, sorry, it was not here, it was this one here. In our list of issues, we can change the status of these issues by clicking here, okay? There is a new, another way to solve the information. When we export this information again, the status of these issues will be changed from pending to solved. And here inside of the solved list of issues, we can see those issues that were solved. Okay, so this is how we can see the issues. Another way to see the issues is by synchronizing the IFC that content these issues with the design softwares. Let me show you. If we come back here to the projects and open the intro open BIM in this case, inside of the content of this project, now we have a new file that was generated now with this size, in this case by me, and the file it's the issues found by Afonso, the file that we created. So this is an IFC file, okay? We can see this IFC file, for example, here inside of the 3D model that we can see on the browser, the web browser, just opening the file here, the 3D model here on internet. This is one of the ways that we can consult these issues, graphically consult these issues, okay? So let's open the information. So here we have the 3D model. We can deactivate some of the layers of the project. Let's suppose, for example, we want to deactivate the spaces, the furniture, or even the landscape, okay? And let's activate the issues. The issues in this case found by Afonso. Here you can see there is a new layer of information. Could be found by Afonso, found by John, found by Mary, different analyses that were made. And in this case, they were structure versus sanitary. So let's activate the structure and the sanitary analysis here, okay? So if we minimize here we can find the issues, and now you can understand why that red dot is very important, because it's much easier to see a red dot like this one than just the annotations that we added here, okay? And we can also consult this information by clicking on this this arrow here. So we can click here and we can see what is the content of this issue here. So we have the sanitary pipe inside of the foundation element. So the information that was created with Open BIM Model Checker, okay? And we can do that here on the platform online. That could be in our computer, in our mobile phone, in our tablet, but we can also come back to the analysis software or the design software. In this case, I don't know, CYPE architecture or CYPE plumbing, CYPE CAD, and this button here, now it's flashing, okay? So we can see that the update button is flashing because some files were created after the last time that we updated the model. So in this case, one file created by Afonso that is called issues found by Afonso was created. Another one that is the analytical model created by Victor, it was also created. Some of them were changed, okay? So here we can find this information. The platform is telling us about these changes. So let's update and let's import these issues to my software that I use it to design one of the disciplines of this project. For example, in this case could be the issues. Where are the issues? Issues found by Afonso. So let's accept. And now we are again downloading information from the platform. So here you can see how the professionals can exchange information, always sending and receiving information using these two buttons of export and update. Okay, so now we are downloading the issues from the platform to CYPE architecture, or could be to site plumbing, site CAD. Okay, let's wait a little bit. Actually, we had more changes in the model in the meantime, not just the issues. So we are also downloading this information. And here we can click on one of the views and activate the issues. Okay, so the issues found by Afonso. And our red dot is here. Okay, our red dot is here. And by clicking on the view information, we can see this information. Okay, so it's the same situation that we have in the platform, but inside of the software in this case. Okay. One last thing, I would like to show you one last thing that could be very interesting. Maybe we start constructing this building, and maybe we can have some doubts during the construction of this building. Okay, so we can use the mobile phone to send information directly from the construction yard, directly from the building when we are constructing to the professionals that are related to the project, using the same system. Okay, let me show you one example. We have here a project. It's a very simple project, but it's very interesting because we have some issues during the construction of this. Let me remember how was the name of that. Let's see if we find it. My connection is not that good today, I think. Yeah, let me update the page. I think it's not loading. Yeah, no, let's use that. Yeah, this project here. Okay, it's a very simple project. It's just a swimming pool. But here on the notifications tab, we had some problems during the construction. So, for example, the heat pump system of the swimming pool, we had a doubt where it was not clear if the inlet and the outlet pipes were installed in the opposite way or if they were okay. So using the mobile phone, you can take a picture of the problem that you have and send this information to the team. Okay, so in this case, it was a consult just to check if the outlet pipes in inlet pipes were okay. So by adding a text and a picture, you can do that in your mobile phone. Or in this case, for example, the wooden column anchor plate was missing for some fixing. So the same situation. In this case, to another IFC or to another professional of the project. So you can use this system. It's very, very interesting. You can also create your own system, your own issue here on the platform. So my new issue. You can add a description for that and then select one of the IFCs that are related to the issue. In this case, you cannot add a picture or add multiple different IFCs, or for example, select one specific part of the IFC, but here you can select one of the files and then the person that is related to this file will be notified. Okay. So that was our presentation today. Let me see if we have any question here. So yeah, okay. So Kunal is asking us to I think both of them were answered during the presentation. If the software generate a clash detection, yes, we saw in the second part of the presentation that could be possible. And Kunal is also asking us, what is the meaning of the percentage symbol that we have in the bracket after the pipe? Kunal, I'm not sure, but I think you are talking about, let me open it here. The percentage, I don't know, maybe this one. it's just, actually, this is just the name of the pipe. So CRH pipes 2%, they were a category of pipes maybe related to a specific code that were introduced on site plumbing in this case. Okay, this is just a name. Okay, it's not actually it's going to be related to the depending of the pipe. Okay, it's also here we have also the maybe the manning coefficient of this horizontal circular pipe. I'm not sure if this is the rugosity or any other parameter. So this is just the name of the element on site plumbing in this case. As here for a beam, we have a size or the section of the beam. Okay. All right. So thank you very much for your presence. Thank you very much to coming to this presentation. It was a pleasure to be here with you today. I hope I can see you in a next presentation.